In this video, we'll do an introduction to factoring a difference of two squares and define what a difference of two squares is. The first step to being able to factor a difference of two squares is to be able to identify a difference of two squares. So let's start by multiplying the binomial x plus 2 by its conjugate, x minus 2. Now remember, when we multiply two binomials that are conjugates, the O and the I part, or I say the OI part in the FOIL method will always cancel out. Let me say that again. The O and the I in the FOIL, when we multiply these two binomials, because they are conjugates, will cancel out. So the only parts that we have to multiply are first times first and last times last. When we multiply x times x, we get x squared. And when we multiply 2 times negative 2, we get minus 4. The result of multiplying a binomial by its conjugate is what we call a difference of two squares, or you may hear me say a difference of two perfect squares, or a difference of perfect squares. But when we multiply a binomial by its conjugate, the result is always a difference of two squares. So if we're going to need to factor differences of squares, let's talk about the characteristics of a difference of squares so that we know how to identify them going forward. The word difference inherently means subtract. So anytime we have a binomial and the middle sign is a minus sign, it's a difference, then that's the first thing we look for if we're trying to identify a difference of two squares. Now the two squares part has to do with each of the terms in the binomial. First of all, it's a difference because it's a minus, but then the first term and the second term are both perfect squares. Now let's talk real quick about what it means to be a perfect square. The perfect square is a result of multiplying one number times itself. So in other words, 2 times 2 equals 4. 4 is the perfect square, and 2 is the positive square root of 4. Another example would be 3 times 3 equals 9. 9 is the perfect square, and 3 is the positive square root of 9. One last example, x times x gives us x squared. We would say that x squared is the perfect square and x is the square root of x squared. So the expression x squared minus 4 is a difference of two perfect squares, or a difference of two squares. Well, if I ask you to factor this x squared minus 4, this difference of two squares, how will it factor? Well, remember, the process of factoring a polynomial and the process of polynomial multiplication are opposite processes. So we FOILed or multiplied x plus 2 by its conjugate, x minus 2, to get our difference of two squares. Well, now if we want to factor that difference of two squares, the result will be the FOIL that produced that x squared minus 4. So if we factor x squared minus 4, we'll get x plus 2 times its conjugate, x minus 2. So then how do we factor a difference of two squares? What are some things to look for? The first thing we need to know about factoring a difference of two squares is that a difference of two squares will always factor into two conjugate binomials. So when I'm factoring a difference of two squares, I know it's going to be a binomial times a binomial, and those two binomials must be conjugates. So that means when I begin the factoring process for a difference of two squares, I just go ahead and set up my parentheses for two binomials, and because those binomials have to be conjugates, I put a plus in the middle of one and a minus in the middle of the other. The next thing that we notice is that the first term in each factor in my factorization is the square root of the first term in the difference of squares. In other words, the first term in this case in each of our factors is the square root of the x squared. Because when I multiply this term by this term, I have to get an x squared. That means that this term must be an x and this term must be an x. And the last thing that we need to know about factoring a difference of two squares is that the second term in each factor is the positive square root of the second term in the difference of squares. So in our factorization here, our second term in each factor will be the positive square root of 4, which is 2. And that's the basic idea of how to factor a difference of two squares. There is one important thing to note, however. Let's look at this example. We're asked to factor x squared plus 4. The first step to factoring any polynomial is to look for a GCF. When we look at our terms, x squared and 4, there is no coefficient GCF and there is no common variable factor. So we do not have a GCF for this expression. The second step is to count the number of terms, because remember, the number of terms always tells us the strategy that we'll use to factor it. So here we have 2 terms. Well, the only strategy that we know so far to factor a 2-term polynomial is that we need to identify this polynomial as a difference of two squares. If it's not a difference of two squares, we don't really know what to do with it at this point. So the question is this a difference of two squares? The first tip-off that this is not a difference of two squares is that it is not a difference. This expression is a sum. As a matter of fact, this is a sum of two squares, because x squared is a perfect square, it's x times x, and 4 is a perfect square, it's 2 times 2. So this is a sum of perfect squares, not a difference. If we ever run across this situation, we have to know that a sum of squares is not factorable over the real number system. Another way to say that is there's no way for us to factor a sum of squares using only real numbers. There is a way to factor a sum of squares, but we have to use numbers from the complex number system that are called imaginary numbers. So for the purposes of this class and this video, we will say that a sum of squares is a prime polynomial. It is a prime expression, and we cannot factor it. Now, if you're interested in knowing how to factor these sums of squares, then we have a video in the pre-calculus algebra playlist that will walk you through the process of factoring these types of expressions.